In this video, we are going to talk about sessions and cookies in Dancer. So when you are visiting a website, every time you visit the website doesn't really know, can't really know that it's the same person, the same browser that comes visiting. The way it's usually handled is that the website sends and sets a cookie on the web browser, and the web browser sends back that cookie every time the user visits that website. And the web server, the application in the web server maintains all the cookies that it gave out. So it knows a cookie is just a little string basically. And then it knows then that when the same cookie is received, that's the same user again and again. And then different cookies means different, at least different browsers, okay? Then handling users, that's a separate story, but it's at least the same browser usually. Of course, the user can clean the cookies, and this is not perfect, but this is the system that is being done. On the Dancer side, it's used, the word session is used to handle all this. So the way it's done is that when we would like to set a session, we say we say something like we save something in this session. So we call session and then give a key value pair. This is how a session is created or set using Dancer. So when we call this function, basically this is a function, this is one of the keywords of Dancer 2, and give it a key value pair, some string and some value, then this will be stored in the cookie somehow, in the session, let's say, and this basically also sets a cookie on the browser. Now, in this example, what we do is just a simple counter. So we would like to be able to count per user, okay, basically per user or per browser. So what we do is when the user arrives, we have this counter variable that we get from the session, basically from the cookie. Okay, or the data managed on the server for that cookie. But for our purposes, it doesn't really matter. What matters is that it's in the session. So we take the value out. Now, if there was no session or there was no field counter in that session, then Dancer just, in this case, the session function just returns undef. And then because it's Perl, so counter plus plus or undef plus plus will increase it into 1. And if there was already a number, then it will just increase it by 1. And then we save that session, that value again in the counter field. So the first time we access this page, this will return undef to the counter variable. It will be increased to 1. Then we set the counter field in the session to be 1, and we return to the browser 1. Next time, the same browser actually accesses, it sends in the cookie, and then based on that, Dancer can manage gets the session, the counter from there, which was already 1, then it increments to 2, and so on. Okay, and let's now see how it works. So we are in the terminal, and then run pluckup, and in here I am opening this browser localhost as usual, and it says 1. Okay, and if I reload it, it's 2, 3, 4. Yeah, you can see it in the top left corner, the number increases. Now what happens if I open a new private window? So that private window doesn't know about the cookies in the main one. Okay, that's the whole idea of private windows. That's in Firefox, in Chrome. I don't remember the names for each browser, but each browser has some kind of a session where it forgets all the cookies basically, and it's private. Okay, so now it says it's 1 because it has sends a separate cookie. If I reload, it gets a separate cookie, and it's a separate session on the Dancer side. So now it says 2. If I switch back to the other browser, okay, here, and reload this one, it gets to 6. So now you can see that two browsers, in this case 2 separate sessions of Firefox, have the counter. So I can increase here, that increases 3. And that's it. So this is basically how you manage sessions. Now the interesting part, or even more interesting part, is how do you test this? Okay. Let me switch to the terminal and stop it. So now we have a test script here in the next slide. Okay, in the test slide, what we have is, okay, we just run the plug application. We create, so we load the application as we did earlier. We create the web interface for it, okay, that the plug test provides, and then we send in the request get. We get the response, we check if it's 200 okay, and if it's 1, and that's all so far okay. But then, and this is why it's in the to-do, then if I send it again, I would expect 2, right? That's what we expect. But it won't get 2, it will get you 1. So if I run this test, it's called test T, okay? If I run it prove test.t, okay, it will says that everything is fine because I set it to be a to-do test. But if you actually run it with prove -v, then you will see that the first test passes, okay, we get the 200 okay back and the number, first 2 tests, and then the second one, the second test case, it doesn't pass, okay? So we get 1 again and we are expecting 2, okay? And why does it happen? It happens because in each request, we didn't send the cookie back. So a normal browser, regular browser would send a cookie back, but the way the plug test works is that it doesn't send the cookie back. Okay, it sends a clean cookieless request. So what I still wanted to see whether we even get the cookie. So what I ran is that in the res object, okay, it doesn't really matter if this one or this one, we get to the headers, and there's going to be a field called set cookie, and I extract that, put in this variable, and then diag out, so print it out, and that's basically what you can see here, that it sends that actually yes, there is the cookie and it was set, but the way plug up works, the way the plug test works, it doesn't send it back. So what can we do? There are a couple of ways to do this, to solve this. Oh, and just for one more thing, so what we have here is this to-do mark, it and this explanation here, so in the variable $to-do some explanation. Basically, this tells the test framework of Perl that this test that here is expected to fail. So these usually you would do this something like this when you have a test case that fails already, but you don't have the time to fix the problem behind, so you mark it as a to-do test, so it won't always bother you by saying that it's still failing. Okay, so but how do we write a test? So there are a couple of ways, and one of them is to using the HTTP cookies module and to create a cookie jar. Okay, so the cookie jar, of course, has cookies in it. So we have the same two lines as we had earlier. And then we also create a cookie jar. Okay, so this $jar, of course, any variable name can be there, which is just an HTTP cookies object. We also need to set a URL, so we access a URL, not just basically slash. This is how basically we need for the cookies. And then we send in the GET request. Okay, you could just add your slash URL. So here I put together, it's because it's just a counter, I use it HTTP localhost and the slash. Probably what you would do and is you take the base and add slash something, that would be the pass to your code. So I send it to a request, status line is 200 and the content is 1. Then what we need to do is get this response that we got and call the jar extract cookies. So what it does, it takes from the response object that already has this cookie set, right? You remember previously we saw that it was in the header, the cookie. Now this jar extract cookies takes that cookie from the header and puts it in the cookie jar. So now it's in the cookie jar. Okay, but because it's virtual cookie, so probably it's still in this header as well, but it doesn't really matter because it's in declared with my inside is curly braces, so it goes out of scope. But we still have the jar, which is global in our case, and the cookie is still inside. So we can have a separate subtest. We don't even need to be in the same subtest where now we have to do a little bit more. So we can't just say request and then get base, but instead of that we first call this get base. That will create the request object. So this is what represents our request. And this is using the HTTP request command, so that the get name comes from this module, the HTTP request command module. And so this is the request object. And now we take the jar, the cookie jar, and from the jar we add the cookie header to this request. Okay, and this again, because it's a digital cookie, so this doesn't take the cookie out from the jar really. So the jar still has the cookie in it. But now also the request has the cookie. That's a really nice thing that cookies can like this multiply. Anyway, so now in the request we have the actual request and the cookie, both of them. And now we do this, what we had here, this web request. But in this time we are sending in the already the request that already contains the cookie as well. So now this is the request, and we get back a result object. And in the result object, we can observe that it's in these two. So this file is called test with cookie. And if I run this, prove -v test with cookie, and then if I run this, you can see that all the tests are working. I didn't have the to-do mark there, and it was just printing it out. So that's good, but you probably would like to also test what happens if there are two browsers, two separate browsers, because so how can we check that two users will actually get different counters? So for that we have actually not here, a little bit lower here. Okay, I might put it in a separate page just to make it clearer. Here another test file in which we have we created this thing that we had in the previous test. Now we have it twice. First an application 1, web 1 and jar 1, and then an application 2, web 2 and jar 2. So basically think about as if we had two separate browsers, or one in a private mode or something like this. Okay, and then each subtest here has 1, 1 and 1, 2. So it's which the first number is which one of these applications, and then how many times I call. It's just my naming conversions here. So first request, I just have the request and extract the cookie to jar 1, and then count with that again using that jar 1. Okay, the cookie from jar 1, it gets 2, and then using the same jar 1 again, and now it gets 3. And now I'm trying with count 2, okay, which I'm trying with the web 2, okay, and the response is going to be 1 again because it starts counting again. And now I take the cookie from this response and put it into jar 2. Okay, and then I can play with both. So again jar 1, the counting is 4 now, and again jar 2, okay, cookie jar 2, and now I get 2 here. Okay, and this way you can write a test. Of course, in other cases you won't do this counting probably. In other cases you'll have more interesting things to do. But this is one way to use the cookies and send them back. So in the subsequent request, the web server will be able to understand that which browser is coming. So it can be really interesting. For example, if you have a website with a login system and you would like to see whether we can log in, and then you get a cookie, and based on that user can access private pages, and then the other user who is not logged in cannot access the private pages, or there might be a third user who is logged in again but with a different username password, and then the first and the third, which are both logged in, can't access each other's private pages. Okay, so that could be good. Now there is another solution for this, and that might be nicer. It's using the test www.mechanize PSGI module. So you might know www.mechanize, which is a wrapper around LWP user agent. So it's basically web client, which is slightly or a lot more clever than the regular LWP user agent, and this one is using PSGI to fake the whole thing. So it won't go out to the internet, but it will use the PSGI language basically to do this. So what we need here is, again, we need to load our application. And then we use this module. Of course, you have to install it. Okay, so just you have to install it with cpan-m or cpan, whatever way you install. Then we call the new on this module, on the mechanize PSGI module, so test www mechanize PSGI, and provide it our application. Okay, so that application that we got from the loading the dancer, and we can call it something like $mech. And then in the test case, we can just say mech and get OK. This is going to fetch the page slash, and we can also check whether the content that we got from the page is 1. So it counted 1. And then we send again get OK. So we check again. So this one is going to do a get and check whether we got back 200 OK. This get OK. So it again checks the second time the route, and the number is 2, and third time the route, and the number is 3. So it's less work to do this. And sorry, again, I have the solution in the same page. If you would like to use it with 2 browsers, you create 2 of these applications. So you load the application twice, up1, up2. You create 2 mech objects, mech1 and mech2 in this case, using up1 and up2. And then I have this same series of requests. So with mech1, I expect 1, and then mech1 expect 2, and mech1 expect 3. And then if I go with mech2, it gets again 1 because it's a new counter. Mech1 again goes to 4 because it was 3. And this one, mech2, goes to 2 because it was 1. So this looks much cleaner than the previous one, but it needs this module, this mechanized module, in order to use it. So that's it for testing. And one more thing I think we had here in the sessions example, that was in comment. So these sessions, now if I actually run this again, so remember we had here 6. And if I go back to the command line, if I run again, pluck up and reload this page, you will see that we get back to 1, because the session is managed in the memory of the dancer process. So this is good for development, but it's not really good for production, because you don't want to lose all the memory of all your sessions when you restart the web server. So one way to you can configure that the sessions will be managed by, let's say, YAML files. And you can do this here, or you can do this in the configuration file. Now I'm going to do it here, the configuration file that we saw earlier in the previous video. And now if I run this application and start it again, the counting, it starts 1, 2, 3, 4, that's okay. Let's switch to the other browser. So this one, this is the other browser, so it starts also 1, 2, 3, 4, 5. Okay, I can go back. Okay, that's still, I reloaded 5, and this is going to be the interesting. I can stop it. I can start it again. Okay, and if everything worked, then now it's going to count from 5. So it's going to be 6, 7, and the other browser, which was 5 last time, it's also 6, 7, 8. So they both remembered the numbers. So how does this work? So in this directory now, we have a directory called sessions that wasn't there earlier. Okay, it was automatically created now. In these sessions, we have 2 YAML files for each cookie. Okay, for each session basically. This is, I think, the cookie, and inside that YAML file, it's one of them is this one, Z2. Sorry, this is one of them. So you can look what is in this YAML file. So there is this counter that was saved in the session. Okay, and the other one has the other number. Okay, so that's it basically how sessions are managed. You can of course configure the sessions in in the config YAML file or one of the environments that we saw earlier. It doesn't have to be the YAML. It can be all kind of other formats. It can be in a database. We don't get into that now. It's enough that you know how to handle the sessions for now. So thank you for watching.